Your app is containerized. You ran 3 Docker run commands, you hit localhost 8080, and nothing. Let me show you exactly what's broken, because I lost a full afternoon to this exact mess. There it is, connection refused. The containers are up, the processes are running, and they still can't see each other. This is the #1 Docker mistake people make on day one. They're all running, but on no shared network. By slide 12, all 4 services will be talking, and I'll show you every command that gets us there. Stick around. The floor plan at the end is the one diagram worth screenshotting. Here's where we're going. 4 rooms, web, API, DB, and a cache, all sharing one hallway with a locker for the database's data. That blurred diagram is the destination. The whole deck uses one light analogy. A container is a running room. An image is the blueprint you build the room from. A network is the hallway the rooms talk through. A volume is a storage locker that survives even if the room gets torn down. We'll build this with 6 Docker commands, then collapse them into one. Phase 1. First, give the rooms a hallway to talk through. Everything else is built on top of this network, so we create it before anything else exists. Docker network create, and we name it appnet. One command, one hallway. Watch the diagram, a dashed room appears, and for now it's completely empty. That's the network. A network is just a hallway, the room exists, but no one's in it yet. The containers will move into this hallway in a minute. Docker volume create, name it PG data. The hallway stays dimmed, and a new shape appears on the right, a coral cylinder, the storage locker. A volume is a locker that outlives the room. If the database container ever gets deleted and recreated, its data is still sitting in this locker waiting. The room is disposable, the locker is not. Phase 2. Now build the blueprints, the images the rooms are made from. Before you can open a room, you need the instructions to build it. Docker build, tag it quotes API 1.0 from the API folder. Docker reads the Docker file, snapshots each step into a layer, and stacks them into one image. Watch the shelf, the API blueprint appears. That's an image, 12 layers, 420 megabytes. It's not running, it's not a container yet. It's just the blueprint sitting on the shelf, ready to be opened into a room. Same command, second blueprint quotes web. The API blueprint dims to show it's done, and the web blueprint lands below it on the shelf. 2 blueprints on the shelf, API and web. The database and cache will pull ready-made from Docker Hub, so they don't need building. Now we open the rooms. Phase 3. Open the rooms and wire them to the hallway in order. Order matters here. The database has to be up before the API can reach it. Docker run, detached, name it DB, attach it to appnet, mount the PG data locker into the database's data folder, and use the Postgres image. Watch, the DB room appears inside the hallway. There's the DB room, Coral, sitting in appnet. It's the only room so far, but it's the foundation everything else talks to. And there's the locker bolted on, that short line is the mount. The database writes to its data folder, and Docker quietly stores it in the volume. Data won't die with the room, so DB is up and its locker is bolted on. Even if this container crashes tonight, the data survives. Now we open the room that needs to reach it. Docker run, name it API on appnet, and this time we publish a port, 8000:8000. That's the front door. Watch the API room appear in the hallway next to DB. There's the API room, teal, inside the same hallway as DB. Because they share appnet, they can reach each other by name. API just connects to host DB. No IP addresses anywhere. And there's the link forming. That little packet flowing along the line is API reaching DB through the hallway. The connection works because both rooms are in the same network. The pill on the edge is the front door, port 8000 published to your laptop. The DB didn't get a published port because it should only be reachable from inside the hallway, not from the outside world. So API is up, it can now reach DB through the hallway, and its front door 8000 opens to us. One more room and the app is live. Docker run, name it web on appnet, publish 8080:80, that's the port your browser will hit. Watch the web room appear on the left of the hallway. There's the web room, blue. Now all three core services are sitting in the same hallway, web, API, DB, plus the locker still bolted to DB on the right. And the link forms, web reaches API through the hallway, packet flowing along the blue line. That's the request path your browser takes, web to API to DB. The front door, 8080 published to your laptop. Open localhost 8080 in a browser, and the request walks the whole hallway. In the web door, through to API, across to DB, and back. All four are talking. The promise from slide 1 kept. The cache comes next, but the app is already live. You just wired a 4-service system with 3 Docker run commands. Docker run, name it cache on appnet, and we pull Redis straight from Docker Hub, no build step. Watch the cache room appear below API in the hallway. There's the cache room, Amber, the quick shelf. It sits in the same hallway, so API can reach it by name, just host cache. And the link forms, API to cache, that Amber packet flowing down. When API gets a read, it checks the quick shelf first. If the answer's there, it never bothers the database at all. The quick shelf takes the heat off DB. 4 rooms, 1 hallway, every link wired. Now it looks done, but let's prove it actually works. Phase 4. It looks done, but let's prove it, and peek inside a room. Running containers lie sometimes, so we verify before we trust. Docker PS, this is your running room roster. Watch 4 rows, 1 for each container, color locked to the diagram. 4 rooms, 4 up. Notice the color of each name matches the box color on every diagram: blue web, teal API, amber cache, coral DB. That's not decoration, that's so your eye can track the same object across every slide. Now say the API room is misbehaving, requests timing out. Docker logs, tail 20 lines on API. Watch the diary appear. There it is, fatal, could not connect to DB:5432, bad password. Logs read the room's diary. They tell you what the container saw, not what you assumed. But the log only shows the symptom. Docker exec, interactive, into API, open a shell. The magnifying glass, you just walked inside the room. Now you're standing inside the API container. Print the environment variable, and you see the password it's actually using, secret. That's the one line that tells you whether the problem is in API or in DB. Logs reads the room's diary, exec walks you inside it. 2 tools, 1 diagnosis, and notice you debugged a running container without rebuilding a single image. The twist, 6 commands, 1 typo, a wrong network name, a missing port flag, and the whole hallway breaks. And you'll retype these every single time you tear the app down. There's a better way. Here's the better way. This compose YAML is the floor plan. It declares every room, every link, every locker, every front door in one file. Then 1 command, docker compose up detached. Watch all 4 rooms appear at once in the same hallway with the same links. Compose read the floor plan and rebuilt the exact same building we made by hand. Same links, same packets flowing, same front doors. The diagram is identical to the one we built command by command, but it came from 1 file, 1 command, 0 typos. Same 4 rooms, built in 1 command from the floor plan. No typo roulette, no remembering 6 flags, and the whole thing is version controllable alongside your code. And teardown is just as clean. Docker compose down. Watch, the rooms vanish, the hallway vanishes, everything built by the floor plan is gone. Containers and network vanish, but the volume survives. That's the locker doing its job. Down is reversible because the data outlives the building. Pause and screenshot this. This is the cheat sheet. Every command and the exact shape it adds to the diagram. Network create adds the dashed hallway. Volume create adds the coral locker. Build puts a blueprint on the shelf. Run with network puts a room in the hallway. With a V it bolts on the locker. With P it adds the front door pill. PS, logs, exec verify, and peek inside. Compose Up builds the whole building, Compose Down clears it. And the color map, Blue Web, Teal API, Coral DB and Locker, Amber Cache holds for the whole series. Save this to your prep playlist. You'll reference it in every Docker video ahead. Recap. 6 commands wired a 4-room app, Web, API, DB, Cache, 1 hallway, 1 locker. Then 1 floor plan, 1 compose file replaced all 6. But notice those 2 blueprints, 420 megabytes for the API, 180 for web. Most of that is build tools and compilers you're shipping to production for absolutely nothing. Watch this next, shrink your Docker images 10 times with multi-stage builds. A second workshop stage builds the app, then hands only the binary to a lean runtime stage. Same running room, a blueprint a fraction of the size. Here's the question for the comments. Are you team minimal Alpine or team distroless? Drop your pick below. I'll benchmark both in that next video. And if this clicked, save it to your prep playlist and subscribe so your next deploy survives its first viral moment. See you in the next one.